Hi everyone, welcome to this episode of Kuiper Labs. In today's video we're going to talk about the seasons. So we're going to remind ourselves about the Earth's axis of rotation. We're going to then look at the effect of the angle of the sun. We're going to look at the difference in sunlight at different latitudes. And we're going to see how that connects all together with the seasons and the Earth's position around the sun. And then seeing how we have differences between the northern and southern hemispheres in terms of being able to make sense of why we have seasons. So we know a couple of things about the way the Earth behaves. Firstly, that the Earth is rotating. It rotates on this imaginary line we call its axis. Okay, so that it's continuing to rotate around this imaginary line. But that the axis of the Earth is tilted 23.5 degrees relative to if it was completely vertical. So it's down, so it's tilted down a little bit like that. Okay, and so relative to what we call the orbital plane. The idea is that this is the direction, that's the level at which the Earth is actually going around the sun, and that's 23.5 degrees of tilt relative to that. And so that affects a couple of different things. So you can see from this image that half of the Earth is experiencing sunlight, the other half is experiencing darkness. Okay, so we have day and we have night. Okay, but then the idea of the fact that it's tilted is going to become really relevant. Now, one of the things that we can observe, if you observe outside for long enough, or maybe that you've been aware of it when you look out the window at different seasons, is that the angle of the sun changes over the course of the year. Okay, and particularly that the angle is a lot higher in summer. You can kind of see in this sort of image, and it's a lot lower closer to the horizon in winter. Now, depending on where exactly on the Earth that you are at this given moment or at any other point, that then the exact difference between the summer and winter angle will vary. If you are in, here where we are in Australia, the summer sun tends to go straight overhead. If you might be closer to the South Pole or the North Pole, that the summer sun is still at quite an angle, and then the winter sun is at a different angle yet again. So it really does vary a lot depending on where you are on the Earth, and we're going to look at why in a moment. Okay, but these is one of the things that we can notice. You might have experienced it at your house in terms of areas that are in that get the sun in summer that don't in winter, or vice versa. And part of the reason that where you are on the Earth makes a difference relates to how the Earth experiences that sunlight. So now, clearly this is not to scale, and it's also not the accurate kind of distance. But getting this idea that the sun's rays travel in straight lines, we kind of visualize them traveling in straight lines towards the Earth. That then where we are when the sun is directly kind of overhead, or kind of pointing directly down, that the sunlight is really concentrated. The rays are really kind of focused to a particularly small area, but that when the sunlight is at an angle, it's a lot more spread out. Okay, so if we're seeing, all right, this is spread out over a much larger area than these ones are. We're going to visualize that a bit more in a second. Okay, but so the idea that how concentrated that sunlight is hugely important as to thinking about the seasons. Okay, so here's kind of a way we can visualize it. When the sun is directly overhead, that then the same amount of energy that comes from the sun is concentrated over this kind of small space at an angle of 45 degrees, so kind of tilted, that then it's spread over a much larger area. Okay, so the actual amount of energy that is being experienced is a lot smaller. So more concentrated sunlight is hotter temperatures, higher temperatures. More spread out is colder. The more spread out it is, the colder it is. The more concentrated it is, the hotter it is. And so that's hugely important, saying that, right, well, when the angle of the sun changes, the amount of sunlight that's concentrated on a spot on the Earth changes. And if that changes over the course of the year, that then different times of the year will experience different temperatures. Okay, so you can see that then thinking about how if we have that concentrated over a smaller area versus a large area, we're going to experience summer versus winter. Now these labels are for the Northern Hemisphere. In the Southern Hemisphere, we'd be experiencing the other way around. But seeing that the more spread out it is, the colder it is, which correlates to winter. And so what we also know is that that different latitudes on the Earth, so where you are kind of, if you imagine the Earth from very top to bottom, North Pole to South Pole, where you are relative to the poles and the equator, you're going to experience very different seasons. If you're over the equator, you're not going to experience much of a summer or winter at all. Whereas if you are in the Arctic Circle or the Antarctic Circle, what you experience even in summer is going to be highly different, because the equator gets concentrated sunlight. Okay, so it's always at that point at which the sunlight, the sunlight's really focused on a very small area, and so it's going to be hot all year round. In fact, terms like summer and winter don't really apply if you live somewhere on the equator, like Singapore or tropical kind of Africa or in Brazil or something like that. We tend to talk about wet season versus dry season much more than you'd ever talk about winter. Okay, because it's hot all year round. Very consistent climate. Very hot, but very consistent. Whereas at the poles, whether further towards the north or towards the south pole, because the sunlight is more spread out, it's more cold all year. If you live in the Arctic Circle, it doesn't matter whether it's summer or winter, it's still cold. It's just a matter of cold or extremely cold, really. But this idea that because the sunlight's more spread out, it's more dispersed, this idea that then that temperature is lower. So we've seen that the angle of the sun changes over the course of the year. The angle of the sun is experienced at different places on the Earth, and these two things kind of together describe what we talk about as the seasons. Okay, so one of the things to remember here is that the Earth is continually revolving or moving around the sun in a particular direction. It takes 365.25 days to do it. That the Earth is tilted on an axis, and also of 23.5 degrees. But that only half of the Earth is facing towards the sun at any given moment. As it revolves on its axis, as it rotates on its axis, that then we're getting day and night. But then, depending on what time of year we're talking, that the angle of the sun that we're going to experience is different. Okay, so if we look over here, for example, this is kind of around January and December. The southern hemisphere down here is facing towards the sun. It's getting more concentrated sunlight. The northern hemisphere up the top here is getting much more spread out sunlight. Okay, so it's northern winter but southern summer. If we cross over to the other side of the year, travel 6 months around, that then we have the reverse. That the northern hemisphere is getting more concentrated sunlight. The southern hemisphere is getting much more spread out sunlight. So southern is winter, northern is summer. And then at the halfway points around our September and around March, that it's fairly kind of equal. And so we get an in-between season. We get autumn in the northern hemisphere, spring in the southern hemisphere, depending on whether we're coming out of winter or coming out of summer. And then we get the opposite in March or April. Okay, so the northern and southern hemispheres experience opposite seasons because the angle of the sun is changing, but because of the tilt, that the angle is kind of opposite at the same time of the year for the north and the south. Okay, just to kind of unpack that a little bit further here. So it's summer, the sun's angle is the highest, it's the hottest. In winter, the sun's angle is the lowest, so it's the coldest, it's more spread out. And in between, in spring, the angle is getting higher and higher, therefore we're getting warmer and warmer. In autumn, the angle is getting lower and lower, so it's getting colder and colder. So it's not like all of a sudden we go from summer to winter. We do experience this gradual change in temperatures in between as the apparent angle of the sun is increasing or decreasing. And so then you can see here, just to visualize the northern and southern hemispheres in terms of where the sun is more concentrated versus more spread out. For the northern hemisphere summer, and then the southern hemisphere summer, based on the tilt. Okay, so whatever we're experiencing is the opposite. Okay, and so that's something to keep in mind, based on the difference in this angle. Alright, so we've reminded ourselves about that the Earth is on a 23.5 degree tilt or axis. Its axis of rotation is on a tilt. That the angle of the sun appears to change over the course of the year. We can just observe that by looking outside our window. But then seeing that the angle is higher in summertime and lower in wintertime. We've seen that then at different latitudes that the angle we're going to experience is different based on how much that sunlight is kind of concentrated or spread out. We're seeing that the changing of the angle of the sun has to do with the Earth's position around the sun at the given point in the year. Is it getting more concentrated sunlight, or is it more spread out because of that tilt? and then seeing that the northern and southern hemispheres experience opposite trends in their seasons because of when one's getting more concentrated sunlight, the other is getting it more spread out. All right, thanks very much for watching. Don't forget to like and subscribe. Bye for now.